All right, welcome everybody to CLT Math Crash Course. This is day 3. We've got Karis with us again. Karis, can you say hi to everybody, please?
Hello.
Thank you, Karis. Appreciate it. And the plan for today, we are going to be continuing that strategy, that all-important strategy of plugging in values in place of the variables. We've got some of the homework questions from the end of the day 2 session we're going to go over, and some new questions. We'll also be going over some more word problems and practicing using basic logic, drawing some pictures to eliminate answer choices. And toward the end of the session, we're going to be going on to graphing today, graphing lines, and hopefully we'll have time to get to some circles as well, graphing on the XY axis. Just a little preview of kind of what's coming up. Also, in the day 4 session, we'll be doing sort of a wider variety of concepts they test on the CLT, including functions, percents, probability, ratios, and then we'll also start the geometry, which makes up like 30% of the questions on the CLT. It's a big chunk of them. So we'll be starting that in the day 4 session. But today, let's go back to that plugging in values in place of the variable strategy. And I've got the first homework question actually up on the screen here. If you did this homework question, those of you watching the recording, and you're able to solve it, great. If you saw this one and maybe some of the other new ones, and you didn't know how to solve them, don't worry about it. We're going to go over all those 3 homework problems right now, and it's all going to make sense here. So go ahead, Kara, start us off by reading question number 97 when you see it on the screen.
Okay. If 2x equals 5 over y, then which of the following is equivalent to the expression 2x squared?
Okay. All right, let's do what we've been doing, right? We're going to continue that strategy of plugging in values in place of the variables. Right? Now we've got 2 different variables here. We've got x and y, okay? The temptation here maybe is to start by plugging in a value for x, and that's not unreasonable to want to plug in a value for x, but I think it makes more sense to start with plugging in a value for y here. And I think you'll see why that's the case here in just a moment. So let's start with coming up with a value for y. What value should we plug in for y here? Do you have any ideas?
Like any random number, or?
We can do anything. I mean, we could do... What would you like to plug in? What did you plug in when you were doing this for homework?
I actually did not plug in variables.
Oh,
I did it differently.
Okay. We can talk about that as well, possibly. But let's try plugging in some values here. Give me a value for y that we can plug in here.
Let's try 3.
We could do 3. But then if we plug in a 3, we're going to get this expression. 2x equals 5 over 3. And that's just looking kind of complicated. Like, I don't know what value of x is going to give me 5 over 3 on the left-hand side of the equation. You know what I'm saying? I mean, we could figure it out. We could do some algebra. But let's see if we can pick something a little bit easier here. Can I suggest a value?
Yeah.
Yeah. Let's make y equal 1. Or no, I lied. Let's make y equal 5. Let's do that. Okay? Now think about this for a minute. If we plug in a 5 for y, we're going to get a much simpler statement. We're going to get 2x equals 5 over 5. Does that make sense?
Yes.
And of course, what's 5 over 5 equal, Karis?
1.
Yeah. So we'll get 2x. That was a really ugly 2. 2x equals 1. Now we can pretty easily figure out what x is going to be. What's x going to be here?
X would have to be 1.
Nope. 1 wouldn't work, right? Do you see why 1 wouldn't work?
Yes.
Yeah. And we can do some algebra. It's not complicated. It's like one step to find out what x has to be. You might be able to just kind of look at it and figure it out logically, or maybe we can just do a simple operation. How do we find out what x is going to be?
We'd have to divide both sides by 2.
Exactly, divide both sides by 2. So you could do the algebra there. It could be like, okay, 2 times what number is going to give me 1? Well, it's going to be 1/2, or 0.5, same thing, right? But we could also just divide by 2. That gives us x. So x is going to be 1/2. Does that make sense?
Yes.
Okay. Again, we could plug in a 1 for y. We could have done that, but I think x would be like 2.5 or 2.5, and you're just dealing with bigger values. And just the more complicated the values, the more complicated a plugging in values question gets. So, I think you want to make this as simple as possible, and plugging in a 5 for y makes this really pretty straightforward. Any questions so far? Is this making sense?
This makes sense.
Okay, great. Now this is a different question, right? Because we're trying to figure out which is equivalent. What's equivalent mean, by the way?
Equal.
Just equal to. That's all equivalent means here. So which is equal to the expression 2 times x to the power of 2, but if x is 1/2, this is now a different question. It's what's equivalent to 2 times, in parentheses, 1/2 squared. That's what we're looking for. Does that make sense?
Yes.
Okay. All right, so how do we simplify that? We're going to have to simplify that, I think, before we move on. Do you have any idea how to simplify that?
Going ahead and squaring the 1/2?
Yeah, we'll square the 1/2, right? And you might be thinking like, okay, what's the operation there? What am I raising to the power of 2? But just think about, again, I think we talked about this in the last session. Don't worry about operations. Think about what that means. What does it mean to raise something to the power of 2, Karis?
It's times itself.
It's multiplied by itself, absolutely. So that expression equals 2 times 1/2 times 1/2. Does that make sense?
Yes.
Okay. What's 1/2 times 1/2?
1/4.
1/4, absolutely. For anybody watching the recording doesn't remember how to multiply fractions, right? You just multiply the numerators and you multiply the denominators. Okay? So that's going to give us 2 times 1/4. What's 2 times 1/4?
That would be 2/4 and then 1/2.
Yeah, absolutely. Let me make that really clear again for anybody watching the recording, kind of how that works. When you're multiplying a whole number like 2 times a fraction, I think sometimes it's easier just to turn that whole number into a fraction. 2 is the same as 2/1, right? So we're multiplying that by 1/4. We'll get 2/1 times 1/4. Once again, you multiply the numerators and you multiply the denominators. We'll get 2/4, which equals, as you said, 1/2. Does that make sense?
Yes.
Okay. Any questions at the moment?
Nope.
Okay. So this expression 2x squared equals 1/2 when x is 1/2. Okay. So now all we got to do is to pick the answer choice that gives us 1/2. Okay. I'm going to clear some space here on the whiteboard. But remember, y is 5. That hasn't changed. We set that value. It's still 5. Okay. So let's plug in a 5 for y into the answer choices, and let's just see what happens. Can I see you work this out on the whiteboard?
Just plug that into the first answer choice?
Absolutely. We'll plug in that 5 for y into answer choice A. Looking good, looking good. Okay, and remember, we're looking for 1/2 is what we're looking for, right? So, true statement, or is that equivalent to 2x squared when x is 1/2?
No.
No, clearly not. So answer choice A is gone. What about answer choice B? I'll clear some space and go ahead and plug it in. Looking good. And remember, you're only squaring the 5 here, right? So you're going to multiply 2 times 5 squared. What does that give us?
Oops.
You can feel free to write a little bit bigger on the whiteboard. Just make it really clear. There you go. So we get 25/50, which equals, you can simplify that, absolutely equals 1/2. So let's keep answer choice B, okay? But I wouldn't stop here, again, especially because we're creating our own values. We discussed this a lot, I think, in the last day 2 session, right? Like if you're just plugging in the values they give you and answer choice B works, you can stop there. But here we've created values for x and y. So I think we need to test all the answer choices. So let's plug into answer choice C, but we'll definitely keep B because B works and gives us an equivalent expression. looking good. All right, looking great. Is that going to give us a true statement? Is that going to give us 1/2, basically? That's sort of the question here.
No, that'll be 1/4, right?
1/4, absolutely. Yeah, the 25 is going to cancel out, right? You've got all multiplication here, right? You've got 25 in the numerator, 25 in the denominator. It's all multiplication, at least across the numerator and across the denominator. Yeah, you can just cancel the 25s out. You're left with 1/4. Does that make sense?
Yes.
Yeah, so C is gone. Maybe you could have just looked at C, right? Because you see, obviously B works. We've got 25 over 2 times y squared. There's just no way 25 over 4 times y squared is going to work, right? You're going to have a larger value in the denominator for answer choice C. But anyway, let's go ahead and plug into answer choice D as well. I'll clear some space here. All right, looking good. Is that can equal 1/2?
Nope.
No, that's going to be 2. So it's not D. We can confirm it's answer choice B. That's the right answer. Any questions about this one?
No, I don't think so.
Okay. How did you solve it?
I got the wrong answers.
Oh, okay. All right. Well, let that be a lesson, right? Anybody watching the recording and to you. There's an algebraic way to do this. I'll be honest. I'm not certain what it is. I'll also be honest. I don't really care what it is right now. You don't need it on a question like this. Most equivalent expression questions, you can just plug in a value. It has to work. So, again, it could be a little tricky if you plugged in a 3 for y or plugged in a 1 for y. It could be a little trickier. It would still work. Just the arithmetic gets a little more complicated with some other values, but it works really well for when y is 5 here, for sure. Any questions?
Nope.
Okay, cool. Let's do the next question. Again, this is also from the new homework questions after the day 2 session. So these should be familiar if you tried these. Go ahead and read question 104 for us, please.
If x times y times z equals 40 and x equals 10 over z, then what is the value of y squared?
Okay. Woo. What are we solving for here, Karis?
The value of y squared.
Yeah, what's the value of y squared? What's the value of y squared? Okay. We're going to plug in values here again. We're going to do that. Okay, we're going to do that. I want to start with plugging in values into this expression right here. Okay, and we could start with the left-hand side, but then we're going to have to pick like just the right values for x and z that give us a true statement. On the right-hand side, it might work out. I don't know, but I think it'll be easier if we start by plugging into values into the second equation. Okay, because there's a value for z. I'm just looking at this. I know what I want z to be right off the bat. Just looking at this. You know what I'm saying?
I think so.
What do you think z should be? It's going to make this really easy.
10?
Yeah, make z 10. Absolutely. You could also make z 1 and make x 10, but something like that, right? Something along the lines is going to simplify it. I wouldn't make like x equal, 5 here or something like that. I guess you could do that. It would work. But it's going to be easier starting with the expression on the right-hand side here. So you said z is 10, is that right?
Sure.
Okay, so I'm going to set that value, z is 10. And then what's the x value?
That would have to be 1.
That's got to be 1. Absolutely. Right, because 10 divided by 10 is 1. Okay, great. We got those values. Now let's figure out what our y value is going to be. If z is 10 and x is 1, what's our y value going to have to be?
Looking at the other expression, it would have to be 4.
I think it's going to have to be 4. Yeah, I think our y value is going to have to be 4. Let's see if we can confirm that. Let's plug our y, x, and z values into the expression on the left-hand side, and let's make sure that works. Can I see you work that out on the whiteboard? yeah, absolutely that works. Right, 4 times 1 is 4, times 10 is 40, beautiful. And double checking the right-hand side again, 1 equals 10 divided by 10, beautiful. This works. This works. So we've got values that work for both equations. I think we're good. Remember, we're solving for the value of y squared. So what's y squared going to have to be? You should just be able to look at this.
That should be 16.
It's going to be 16, because 4 squared is 16. Absolutely. Answer choice B. Any questions about that?
That was a whole lot easier than what I tried to do.
Yeah. Dare I ask what you tried to do here? Dare I ask?
I attempted the algebra.
Yeah, don't do that. Don't do that. Not a question like this. No. No, plug in values. Just start there at the very least. It works most of the time on a question like this. It's fast, it's easy, it's accurate. Just works. Once again, I don't know exactly how. I mean, I could figure it out. I didn't even attempt it. It's just I knew I could plug in values here, so that's what I did. But it's tricky. Algebra here is tricky. And you didn't get B?
I didn't even answer it.
Okay, you spent some time on it, got stuck. Yeah. Plug in values. Plug in values. Just works. Any questions?
Nope.
Okay, good. All right, we got one more from the homework. This one's a little trickier. This involves some negative exponents. We're going to talk about the properties of exponents here in just a moment. Go to read question number 112 for us, please.
If k is an integer, k to the 19th power is less than 0, and a is a positive integer greater than 1, then which of the following must be true of a to the 3 times k power?
Yes. Woo! Woo! Did you attempt this one algebraically?
I read it and we got scared.
Okay. Okay. Boy, I totally understand. Well, let's try plugging in values here. Let's try plugging in values. Give me a value for k. What do we need to make k equal?
1.
I don't think 1's going to work.
Okay.
Because of this expression right here, this inequality. It says k to the power of 19 is less than 1. Which means what about k to the power of 19?
It would have to be negative.
It's going to have to be negative. It's going to have to be negative. Okay? I think we might have talked about this in the last session. I want to go back to the basic concept study guide real quick. And I've got a section on the properties of exponents. I'm scrolling down right now. Here we go. So go ahead and open that up and scroll down to basic concept E. That's the properties of exponents. And I want you to read the second bullet point for me, please.
Negative numbers raised to an even power become positive.
Okay. And that makes sense why that's the case?
Yes.
Okay. All right. And then read the second half of that, please.
Oh, negative numbers raised to an odd power stay negative.
Yeah. If it's an even power, let's say to the power of 2. In the example here, we've got negative 2 to the power of 2. You're going to get negative 2 times negative 2. That's going to have to be positive because a negative times a negative is positive. But once you add an odd power, right, then you've got that positive number, whatever it is, right? Because, if it were even, it would be positive. But then you're multiplying it again by a negative, and a positive times a negative is going to be, negative. So going back to the question, we see an odd power here in the question, right? It's k to the power of 19. So as long as k is negative, we'll get a negative value for k to the power of 19. I say just make k equal negative 1 here. You know what I'm saying? I mean, negative 2. Sense. Yeah, negative 2 would work, but I don't want to calculate, negative 2 to the power of 19. I don't want to deal with that. You don't have a calculator on the CLT, so. But I know what negative 1 to the power of 19 is going to be. What's negative 1 to the power of 19?
Negative 1.
It's going to be negative 1, absolutely. So negative 1 works here. Okay, and then a is a positive integer greater than 1. So what are we going to make a equal?
2?
Yeah, why not, right? I mean, you could do 7, but let's just keep it simple. Right? Let's keep it simple. Pick smaller values if you can. If those don't work, you can try larger values, but start with smaller values. In general, I recommend it. Unless sort of like the last question, right, where it made sense to make z equal 10 or the other question where we made y equal 5. Sometimes it makes sense too, but here just pick smaller values. Okay. So now the question is, which of the following must be true about a to the power of 3 times k? Well, we can rewrite this expression now with these values. It's a lot more easy to understand. We're going to get 2, right, if a is 2, to the power of 3 times negative 1. Does that make sense? Why that's a to the power of 3 times k?
Yes.
Yeah, we're just plugging in those values. Okay. That's going to be the same as 2 to the power of negative 3. Is that clear?
Yes.
Yeah. Okay. Okay. Now you need to know a little bit about the properties of exponents here. In this case, negative exponents. Negative exponents. But I've got a section here on the basic concept study guide addressing negative exponents. Let's discuss this real quick. And I don't even have an explanation. I just have an example that makes sense of it. So go to basic concept E on the study guide if you got that. Do you see that example that I give you there on the study guide?
Yes.
Yeah. So 3 to the power of negative 2. Okay. When you see a negative exponent, all it means basically is you flip the numerator and denominator. That's it. That's it. Now you might be like, there's no denominator here. Well, there is, because 3 is the same as 3 over 1. Right? 3 divided by 1 is the same as 3. So you flip the numerator and denominator, you get 1 over 3 squared. So basically you flip the numerator and denominator, and then you raise it to the power, but the power is made positive now. Does that make some sense, what the operation is?
Yes.
Okay. Okay. Have you seen these before, negative exponents?
Just a little bit, yeah.
Okay. Okay. So in this case, right, it's 1 to the power of 3. 1 over 3 to the power of 2. 3 to the power of 2 is just 9, so it's 1 over 9. Okay. I don't see these a ton on the CLT, but it pops up here, so it's worth noting. Let's go back to the question. So we can simplify this expression out 2 to the power of negative 1, 3. 2 to the power of negative 3. Remember, we just flipped the numerator and denominator here. Let's start there. So what does 2 to the power of negative 3 become?
That would be 1 over 2 to the power of 3.
To the power of 3. Yep. And the power is made positive. Okay. What's 2 to the power of 3?
8.
8. So it's just 1 over 8. That's what we get for those values. Any questions about that?
Nope.
Okay. 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 Well, let's test the answer choices now. Go and read answer choice A for me, please.
It is a positive whole number.
All right. Does that have to be true for a to the power of 3k?
No.
No, it does not. Clearly, it's not the case here. So it doesn't have to be true. It's possible when you're plugging in values like this, you might get multiple true statements. It's possible. I don't think that's going to happen here. But if it's not true, it doesn't have to be true. So we can definitely get rid of it. Answer choice A is gone. What about answer choice B? Go and read that for me, please.
It is a negative whole number.
Does that have to be true?
Nope.
No, it certainly doesn't have to be true. And it's not the case here. Go and read answer choice C.
It is a positive fraction.
Does that have to be true?
It is true in this case.
It's true in this case, so we'll keep it. I don't know if it has to be true or not. We'll find out when we read answer choice D. Go and read answer choice D for me, please.
It is a negative fraction.
Does that have to be true?
Nope.
No, it does not have to be true. So it can't be D, therefore it has to be C. Okay. If possibly, you were plugging in values in a question similar to this, and C and D gave you true statements, or at least for the examples, for the values you plugged in, just plug in another set of values, see if you can get rid of one of the answer choices. That doesn't have to be true. But your best friend on a question like this is really elimination. Okay. It could be C, but if it's not A, B, or D, it has to be C. It has to be C. Does that make sense?
Yes.
Okay. Did you try this one? Did you say or no?
What was that?
Did you try this one on your own, like doing algebra?
No.
No. Yeah. I don't even know how to think about it in terms of variables. It's just too much going on. But you can pretty easily figure it out with values. Okay. Any questions for me?
No, I don't think so.
Okay. I think that's about as complicated as it gets, those last 3 questions with plugging in values. But even those aren't too bad if you approach the questions the right way. Okay. All right. We're going to change gears a little bit. All right, so we're done with the homework questions. These are new questions for you and anybody watching the recording here. And these are actually still plugging in values questions, but they look a little different. Because these are word problems. All right. You see that question on the screen? Question 120?
Yes.
Okay, great. Go ahead and read question 120 for us, please. We'll discuss this one.
A soccer player kicks a ball straight up in the air. The equation h times t equals negative 16 times t squared plus 8 times t feet approximates the height in feet. ht of the ball t seconds after it was kicked. How many seconds after being kicked will the ball reach its greatest height according to this equation?
Oh boy, a lot going on here in this question. A lot going on. Okay. This is a special kind of equation here called a function. Have you seen functions before?
A little bit, yes.
A little bit, yeah. I would read this expression right here, by the way, as h of t. H of t. All right, I wouldn't read that as ht. It's different from h times t. Okay, that's not what h of t means. H of t would be function notation. Function notation. I want to talk about functions a little bit. We'll spend some more time on this a little bit later in the course, but I think it's helpful just to have the idea of how functions work, have that straight here. So I'm going to give you a function that's not directly related to this question, other than the fact that it's a function. Okay, we're just going to talk about how functions work. So here's a function. It's a simple function. It's a linear function. This would graph as a line. It's just f of x equals 2x plus 1. Okay, and again, you'd read that as f of x. Okay, it's not f times x. That's not what it means here. It's f of x equals 2x plus 1. Karis, if I said find f of 3, do you know what that means? Find f of 3?
I think so, yes.
Yeah. What's that mean?
I would take that 3 and plug it in for x
Absolutely.
in the right half of the equation.
Absolutely. Where there was an x, and now there's a 3. So you're literally just replacing the x's with 3's. So you'd get 2 times not x, but 2 times 3 plus 1. And what does that give you, by the way?
That would be 7.
Yeah, it gives you 7. So you'd say f of 3 equals 7. All this means, by the way, is it means when your x value is 3, when that's your input into the function, your output in the function is 7. Okay. Functions kind of also work, like if we graph this function, f of x equals 2x plus 1, it would graph the exact same way as y equals 2x plus 1 would graph. Y and f of x are basically synonymous. It's the same thing. Sometimes I describe f of x as fancy y, right? But you would kind of understand f of x as maybe a variable, right? Just like you describe y as a variable. Or we could describe sort of h of t as a variable, right? It's not variable h times variable t. That's not what it means here. H of t is some unknown value. In this case, I believe it's the height of the ball. H of t is the height of the ball. Does that make some sense?
I think so.
Okay. We're going to come back to functions a little bit more. The key takeaway here, I think all you need to know is when you're plugging in values for functions, like when we're plugging in a value for t, which we're going to do here in just a minute, you're just replacing the t's with the values you're plugging in for t. That's all it means. That's all it means. So if we're finding like h of 0, which we're going to test here in just a minute, you're just plugging in a 0 for t. That's all it means. I recommend students think of functions in terms of inputs and outputs. Inputs and outputs. So once again here, for f of 3 equals 7, your input into the function is 3, your output in the function is 7. Okay? And don't feel like you have to have a perfect understanding right now. They don't test on functions a ton on the SAT, or on the CLT, I apologize. They test one on the SAT. They don't test them a ton on the CLT. But we'll address some more function-specific questions later coming up. But I just want you to be aware of how they work here for this question. All right, I'm going to clear some space here. Let's go back to what we're solving for here in this question. What are we solving for in this question?
The number of seconds.
The number of seconds...
After being kicked.
The number of seconds after being kicked where the ball is at its greatest height. That's what we're solving for. Yeah, it's very specific, right? Do you see that now in the question?
Yes.
Yeah. How many seconds after being kicked will the ball reach its greatest height, according to this equation? Okay. This is easy. Relatively easy. Because they give us 4 possible values for t. These are our t values here, right? T is the time in seconds, right? They tell us that. Do you see that?
Yes.
They give us 4 possible values for t. Let's just test them. All we need to do is plug these into the function, Karis. That's all we need to do. Is plug them into the function for t. And then we'll see which gives us the greatest height. That's it. I think the trickiest part here, besides sort of understanding how functions work, just doing some arithmetic here because we've got decimals. We might turn them into fractions. We'll see here in just a minute. But that's all we're doing. We're plugging those t values from the answer choices into the function, seeing which gives us the greatest height. Does that make sense?
Yes.
Let's do it. Let's start with answer choice A. We'll plug in 0 for t. So we can rewrite this function. I'm going to start it. We can rewrite it h of 0, right? Because our t value is 0. Notice again, this doesn't mean h times 0. That's not what it means. It just means 0 is your t value in the function. That's all that means. 0 is your input. Let me see you work this out now. Plug in the 0 for t into the function. We'll see what happens. Looking good. Okay. Yeah, 0 squared is just going to be 0. Excellent. 8 times 0 is going to be 0, right? But what's negative 16 times 0?
0.
Yeah, it's going to be 0. It's going to be 0 on the right-hand side. Everything's going to be 0. Does that make sense?
Yes.
Okay. By the way, you could say h of 0 equals 0. Again, it doesn't mean h times 0, but when you plug in a 0 for t, the height of the ball is 0. This should make so much sense, by the way, right? If t is the seconds after it was kicked, right? That means 0 seconds after it was kicked, Karis. 0 seconds after it was kicked, so it hasn't been kicked yet. The height of the ball above the ground is 0. It's still on the ground before it's been kicked. Does that make sense?
Yes.
Yeah. That's what it means there. Okay. And that's why h of 0 is 0. Okay. I'm guessing that's not the greatest height because we haven't even kicked the ball yet. It's still on the ground. So let's try answer choice B. We'll plug in 0.25 seconds. Now here we've got a choice to make. Do we want to deal with fractions or do we want to deal with decimals?
I have no idea.
I'm guessing fractions are going to be easier because we're squaring the t value. You know what I'm saying?
Oh.
I don't want to deal with 0.25 times 0.25. But I know what 1 over 4 times 1 over 4 is. I can figure that out pretty easily. You know what I'm saying?
Okay.
Yeah. I'm going to make a note real quick, by the way, of the height. So at 0 seconds, the height is 0. So let's plug in, we'll turn 0.25 into 1/4. I hope that makes sense why that's the case. And if you could divide 1 by 4, and work that out using some long division to confirm that. But I think most people are familiar with the fact that 0.25 is 1/4. If you're not familiar with that, by the way, look at 0.25 and think in terms of money, right? Think in terms of money. How much money is $0.25?
A quarter.
A quarter. That is a quarter of a dollar, right? And a quarter is 1/4. Does that make sense?
Yes.
And by the way, 0.5 is going to be 1/2 in case that's not obvious, because 50 cents is half a dollar. So you can always think in terms of money, if that helps you understand. Going back and forth between fractions and decimals. All right, so let's plug in 1/4 for the t value. So again, we could say h of 1 over 4 equals, and then let me see you plug in 1/4 for t, and let's see what happens. Looking good. Excellent. Let's simplify this. Again, we just need to square the 1/4, right? That's what we're raising to the power of 2. I'm going to stop you real quick. 1/4 to the power of 2. What does that mean?
That's going to be 1/4 times 1/4.
1/4 times 1/4, right? This is exactly what we were talking about last time. You're thinking in terms of operations here. We're just thinking incorrectly about what it means. Because you know what 1/4 times 1/4 is. It's not going to be 1/2. What's 1/4 times 1/4?
That'll be 1/16.
1/16. Right? Remember, because you multiply the numerators. 1 times 1 is 1. You multiply the denominators. 4 times 4 is 16. It's 1/16. Does that make sense?
Yes.
I can't emphasize that enough. Think about what the notation means. Let that guide you, and you'll avoid a lot of common mistakes. Okay. All right, let's continue. Yeah, that's just 2, right? 8 times 1/4 is 2. Okay. How do we simplify this? What's -16 times 1/16?
I'm not even sure.
Yeah. I'm going to rewrite this. Remember I said sometimes it's helpful that when you're multiplying a whole number by a fraction, sometimes it's helpful to just turn that whole number into a fraction. So -16 is the same as -16/1. Right? Times 1/16. This is all multiplication here. We've got a 16 in the numerator and a 16 in the denominator. What can we do there?
It would cancel out.
Just cancel out. Absolutely. So what's that going to be?
-1.
-1. -1. Yeah. I mean, really, anything times its reciprocal is 1. You know, 3/1 times 1/3 is 1. 100 times 1/100 is 1. And that's really the case here, except it's something negative times its positive reciprocal, but something negative times its positive reciprocal is going to be -1. Or you could just look at it like, multiply those fractions, and then, the numerator and denominator cancel out. Regardless, you're left with -1. Any questions about that, or does that make sense?
That makes sense.
Okay. So we got -1 plus 2. What's -1 plus 2?
1.
1. That's 1. Okay. So I'm making note of that height. I don't know if that's the answer or not. But that is going to be a height of 1. I don't know if that's a meter or a foot. I don't think that's... Oh, it is feet. Okay. Doesn't seem too high. But let's test the other answer choices. Let's test answer choice C. Okay. I want to do the same thing with C that we did with B. I want to turn that into a fraction. This might be a little bit easier, actually. Because what is 0.5 going to be as a fraction?
1/2.
1/2, absolutely. So we're testing answer choice C. We're plugging in a 1/2 for the t value. Let's find out what that equals. Let me see, work that out. Looking good. All right, all right, all right. Very good. Very good. Didn't get tripped up there, right? Did you think about what 1/2 to the power of 2 means?
I did. I had to slow my brain down.
I love it. I love it. Don't just do stuff. You know what I'm saying? Like, I just see that all the time with students that struggle in these tests, right? Is they just see something and they start doing stuff. And yes, I love it. Slow it down. Think about what it means, and then you'll know what to do. Think about what it means. Okay, yes, 1/2 times 1/2 is 1/4. Good. And then what's 8 times 1/2? Just 4, right? Half of 8 is 4. I mean, come on. Excellent. All right, what's -16 times 1/4? Don't be intimidated by that. I mean, do you want to turn it into a fraction? Would that be helpful?
Maybe, but I mean, I could see it's going to be 1/4 of 16.
Yeah, and what's 1/4 of 16?
That would be 4.
That would be 4, yeah. But of course, 16 is negative here. So it's going to be -4. Yeah, absolutely, right? Isn't that cool, though, right? You could just kind of think about logically, right, what that means there without doing an operation. If you understand what it means. Yes, this is 1/4 of 16. We're just dividing 16 by 4, or -16 by 4. Okay? So get -4 plus 4, which is going to be 0.
0.
Yeah, E. Okay. All right, so now notice, by the way, the ball is dropping. It's dropped back to the ground after 0.5 seconds. This is not much of a kick. Clearly. Not much of a kick. It might be tempting to stop here. You probably could, right? Because if it's hit the ground, I guess it like hits the ground and bounces way up again. I don't know. Let's just plug in a 1. I think it's going to be real easy to plug in a 1 for T to confirm it. But I'll bet it's going to be B. I mean, it's looking quite good right now. Does that make sense why B is looking good?
Yes.
Yeah. Yeah, because the ball's gone back down to the ground. All right, well, let's plug in a 1 for T. And I think the arithmetic here is going to be really straightforward, so plug it in, let's see what happens. Looking good, looking good. Just going to be -16 there. Eek. It's going to be negative, right?
Yep.
The ball apparently has plummeted into the ground, or been driven into the ground. After 1 second. I don't know how that works, but that's definitely not going to be the greatest height. Definitely not. -8. So what's the answer here?
B.
Let's B. Any questions about that?
Nope.
Yeah. That's not too bad. That's not too bad. There's a way to factor this also. You could do some factoring. I don't know. I would just plug in the values here. We might do some factoring and some questions coming up later today. Are you familiar with factoring quadratics? Have you done that?
A little bit.
Yeah, it's kind of tricky. It's kind of tricky. We'll probably talk about it soon. But here, the easiest thing is just to plug in the values. That's it. Any questions?
Nope.
Okay. So a couple key takeaways here. One is just know how functions work. And what things mean in a function. You will get the height of the ball when you plug in some value for T. That's what it means. So plug in the values for T and find out what the height is. And then just directly answer the question and find out what T value gives you the greatest height. And that's it. Any questions?
Nope.
All right, great. Okay. Kind of a similar question here. We've got another ball being kicked. They like these questions, apparently, on the CLT. Go and read 1 and 9 for us, please.
How do I even pronounce that name?
I don't know. Siobhan? Siobhan? I don't know. I don't really care. You can say S. Okay. And by the way, I see this a lot on word problems. Like, they give you some funky names that are difficult to pronounce. I apologize to anyone named Siobhan watching this recording. How we're butchering the pronunciation, but you can just say S. Like, don't waste time on the test trying to pronounce anything. S is kicking soccer balls. Yeah.
Okay. S is kicking soccer balls across the field. On one of these kicks, the soccer ball lifts into the air and returns to the ground. Its path can be represented by the equation S of t equals -16t squared plus 32t plus 48, where t is time in seconds and S of t is the soccer ball's height in feet after t seconds. How many seconds after S's initial kick does the soccer ball hit the ground?
What are we solving for, you cares?
The ball's height in feet after a certain number of seconds.
No, that's not what we're solving for. No. Read the last sentence in the question again. The thing we're solving for is always in the last sentence. Read it. Read it again for me.
How many seconds after S's initial kick does the ball hit the ground?
Yeah. Yeah. So in your own words, what are we solving for?
How many seconds?
Yeah, how many seconds after his kick does the ball hit the ground? We're not solving for the height, we're solving for the seconds. Okay? When the ball hits the ground. But we know, you've got to make this conscious recognition here. We know what the height of the ball is going to be when it hits the ground, right? I think we discussed this in the last question. What's the height of the ball when it hits the ground?
0.
0, right? It's the height of the ball on the ground. It's the height of the ball when it hits the ground. Okay. So, woo. Okay. So we've got to find the number of seconds that we're going to plug into the function that are going to give us a height of 0. That's what we got to do. Does that make sense?
Yes.
Okay. Now this is a little bit tricky here because the height of the soccer ball apparently is S of t. S of t is the soccer ball's height. It's a little confusing. I wish they made this, I don't know, a lot more logical, like h of t, like they did in the last question. They don't here. This is a little confusing. I think they're trying to trip you up, right? Because you think S is seconds or something like that. But S isn't the seconds. What's the seconds?
T.
T is the seconds, right? The time in seconds. Do you see how they're trying to trip you up here? Does that make some sense?
Yes.
Yeah. But they tell you what S of t is, and they tell you what the height is. S of t is the height. So keep that straight. Okay. Okay. We can plug these in. Same thing. Same thing as the last question, but we're not looking for the maximum height like we were in the last question. We're looking for the number of seconds that give us a height of 0 or an S of t value of 0. Does that make sense?
Yes.
Okay, let's do it. Let's do it. Let's start with answer choice A. So we're finding S of 1. That's it. S of 1. Remember, S of t is the height. I'm going to make a note of that here real quick just to make that really clear. At least as clear as I can with my terrible handwriting. All right, so what's S of 1 equal? Plug it in. Okay, let's simplify that a little bit. This is looking good. I think we can stop here. Is that going to give us 0?
No.
No, it's not going to give us 0. It's just not. I mean, you could carry that out if you wanted to, the arithmetic, but negative 16 is just not negative enough to bring the others down to 0. Not happening. So answer choice A is gone. Any questions about that?
Nope.
Okay, great. Let's plug in a 2 for t. Plug in 2. So we'll find S of 2. I'll clear some space here. And let me see you plug that in. Let's see what happens. Looking good. All right. You know what negative 16 times 4 is?
Not off the top of my head.
What's negative 16 times 2?
32.
Negative 32. So it should just be negative 32 plus negative 32, right?
Yes.
You could also think about it this way. I'm just trying to help you think about, multiplying larger numbers. You're going to see that a lot in the CLT. You know what 4 times 10 is, right?
Yeah, 40.
40. So you just add that to 4 times 6. What's 4 times 6?
24.
24. So it's just 40 plus 24. Of course, it's going to be negative, right? Because we're multiplying negative times a positive. But what's negative 16 times 4 going to be?
Negative 64.
Negative 64. Just another way to think about it. If you wanted to do the multiplication, you could do the whole, negative 16 times 4. It's not too bad, right? You get 4 times 6, which is 24. 4 times 1 plus 2, 64. You're going to make it negative. I mean, that works too. You can do that. But you got some options. as far as what's the easiest and most accurate way for you to think about it. Does that make sense?
Yes.
Okay. Is that going to give us 0?
Nope.
No, right? Because the negative 64 plus 64 is going to be 0, but then you got to add the 48. You're just not going to get 0. So answer choice B is gone. Any questions?
Nope.
All right. I sure hope 3 works, because I really don't want to deal with 4. I really don't. Let's see if 3 works. So we'll find S of 3. Let's see what the height is after 3 seconds. Okay. Looking good. You know what 32 times 3 is?
No.
What's 30 times 3?
90.
Add that to 2 times 3.
96.
You got it. Absolutely. Make sense?
Yes.
Yeah.
That's a whole different way of thinking.
Yeah. Okay. All right, we got negative 16 times 9. Arg! Okay, and we could work this out. It's not too bad. But let's think. I like practicing this. I like practicing what we're about to do. Or what we've been doing. I know what 16 times 10 is. Right? You know what that is. What's 16 times 10?
160.
160. So the right answer should be just 16 less than 16 times 10, right? Because you're adding 1 less 16.
Oh.
Does that make sense? So what's 160 minus 16?
1. Oh, rats.
Let's start here.
100.
Yeah, go ahead.
Sorry, is it 144?
It's 144, absolutely. And you can start here. If you're trying to do 160 minus 16, you can at least take away the 10. You get 150. And then take away 6 more. And that'll give you 144.
Okay.
You can just break it down like that. I hope this is making sense. I don't know if people watching the record are like, I have no idea what you're doing, Mr. Tui. I don't know. I mean, if you just want to do, if you want to do 16 times 9, again, I mean, they don't give you the calculator on the CLT. It's a little bit annoying. I don't know why they don't. But they don't. You just multiply 9 times 6, you get 54. If you need to, look up some videos on how to multiply, feel free to, please do. You're going to have to do it. You got to do some arithmetic on the CLT. Then you get 1 times 9, which is 9, and then you add the 5. 9 plus 5 is 14, so you get 144. Of course, it's going to be negative because the 16 is negative. So negative 144. Or you can think about it the way we're doing it. Whatever you're comfortable with, but find a way. You're going to have to practice your arithmetic for sure on this test. There's no way around it. Okay, so negative 144, and then, is this going to work?
It looks like it.
It looks pretty good. Now, you may not know what 96 plus 48 is. That's okay. You know what 100 plus 48 is, right?
Yes.
What's 100 plus 48?
148.
And it's just going to be 4 less than that, isn't it? Because 96 is 4 less than 100.
Oh.
You know what I'm saying?
Okay.
Does that make any sense what I just said? And you can say no.
I think it does.
Yeah. I mean, again, you know what 100 times 48 or 100 plus 48 is. It's 148. So 96 plus 48 is just going to be 4 less than 100 plus 48, which it is. It's 144. Booyah. Answer choice C. That's 0. We don't need to test D, thank goodness. Do you understand why we don't need to test 4 seconds?
Because if it's 0 at 3 seconds, it's not going to be 0 at 4 seconds.
Yeah, I guess maybe it's like rolling. But like, if they give you an answer that works, they're not going to give you 2 answers that are correct. How about that? They're not going to give you 2 correct answers. And C is correct. Again, we're not plugging in our own values here. We're plugging in the values they give us in the answer choices. And if C works, D ain't going to work. And it won't. I'll tell you that right now. I've tested it. I know it doesn't. I think I did. But yeah, I know it's C. Any questions about this?
No, I don't think so.
Okay. It's not too bad, is it?
No, they made it look scary.
Yeah, they like doing that. But it's just arithmetic. At least here. Yeah, you got to do some algebra on the CLT. You do. We'll be doing some today. But on a question like this, you're just plugging the values. There's a factoring way to do this too. Dare I even teach? I don't think I want to go over it. No, I don't want to go over it. If you're really good with factoring, you can do some factoring. You can practice that as well. There's, and then you just got to find the values for t that give you a 0 for the height. There's a way to do it. No, I'm going to keep it simple. Just plug in the answer choices. That's the best way to think about it. Okay. Any questions?
Nope.
Okay. All right. Let's do this. I'm going to clear the screen here. Okay, now we are really changing gears here. I think we're done with plugging in values questions. We are. But we're not done with balls, apparently. We're not done with balls. We've got more ball word problems here. Go and read question 113. I'll show you how to think about this question.
Okay. A physicist drops a basketball from a height of 120 feet. If it bounces a third as high on each subsequent bounce, how many times does the ball hit the ground before it has traveled over a total of 230 vertical feet?
Oh my goodness. What are we solving for here?
How many times the ball bounces?
Yeah. Before it's traveled a total of 230 vertical feet. Do you understand what the question's asking here?
Mostly.
Okay. Let's do this. I want to go to my rules for CLT Math. I want to go to this. Go ahead and bring that up real quick. And we're going to go to the very top of the rules here. This is basic and this is important. I want you to read rule number 2, right? We finished rule number 1 for now. Of course, you're going to practice this plenty on the CLT in your own prep. But I want you to read rule number 2 for me, please. I think we talked about this a little bit in the day 1 section of the course, but we're going to practice this on some more problems coming up right now. Go ahead and read rule number 2, please.
For word problems, if you can draw a picture, draw a picture. Use logic and common sense to eliminate incorrect answer choices.
Absolutely. This is really important. If you can draw a picture, good heavens. You need to. You've got to think about the question the right way first. A question like this one here is not about operations. It's not. It's just about understanding what the question's asking you and thinking about the situation the right way. And the way you're going to think about the situation describing the question is by drawing a picture. Okay? So let's draw a picture. Okay? We got some crazy physicist dropping a basketball from a height of 120 feet. Let's start there. Okay? Why is he up 120 feet? I have no idea, but he is. All right? So, let me scroll down a little bit here. You know what I'm going to do? I'm just going to zoom out just a little bit. There we go. Okay. That'll work. All right, so we've got, okay, there's the ground. This is 120 feet up here, like a balcony or a platform of some sort. Here's our physicist. I'm going to draw our physicist here. Our crazy physicist. Okay. And he's got a ball that he's dropping. And he's going to drop it 120 feet. Woo! Okay. Now I'm guessing it's going to bounce. We'll get to that in just a minute. But the question says, how many times does the ball hit the ground before it's traveled a total of 230 vertical feet? Okay. Well, let's stop for a minute and think about what that means. Once it hits the ground right here at this point, how many vertical feet has it traveled?
120.
It's traveled 120 vertical feet at this point. Right? We're not worried about how much it's moved sideways, but it's traveled 120 vertical feet at this point. Does that make sense?
Yes.
Okay. I think we're starting to think about the question the right way now. Okay. It's going to bounce. Okay. But notice the question says, if it bounces a third as high on each subsequent bounce. Okay. So it's going to bounce up, but it's only going to bounce up a third as high as it bounced up, or at least a third as high as it was. What's the height of the ball going to be at its maximum after it bounces? It's going to be a third as high. I mean, we'd even draw, before we even try to calculate, just draw it. What would a third as high look like? Something like that. That's close to half. I'm going to make it a little bit smaller. Okay. So what's that going to be?
It would have to be 40 feet.
40 feet. 40 feet. Notice, though, it's traveling 40 feet on the way up. And it's traveling 40 feet vertically on the way down. You see that?
Okay.
Okay. But again, I think drawing the picture kind of clarifies that. Does that make sense?
Yes.
Okay. By the way, how much has the ball traveled vertically so far?
200 feet.
200 feet, right? Because it's just 120 plus 40 plus 40. It's going to be 200 so far. Does that make sense?
Yes.
Okay. Okay. I think we're conceptualizing the question the right way right now. It's going to bounce again. How high is it bouncing now? It's just bouncing. Yeah, it's going to bounce a third as high as on its previous bounce. It'll look something like this. Right? What's the next bounce? How high is that?
Would that be 15?
Something like 15, right? I mean, it's going to be 40 over 3, right? Or 1/3 of 40, whatever that is. It's like 13.3, something or other. I mean, if you want to do decimals or,
okay.
I think 13.333 repeating. You know what I'm saying?
Yes.
Yeah. We'll just say 13.3 for right now. Okay. 13 and a third. Oh, that's kind of small. I'm going to zoom in a little bit again. There we go. So 13.3 repeating. But that's 13.3 repeating on the way up and 13.3 repeating on the way down. Right? So I'm going to add those. That should be like 26.6 repeating, right? Does that make sense why that would be the case?
Yes.
Yeah. How many feet have we gone so far?
226.6 repeating.
Yeah, 226, right? We're close, by the way. We're close to, what does it say in the question? 230 is the total. Okay. 230 is the total. All right. So, and we're at 226 this far. Okay. Okay. Let's do it again. It's going to bounce again. How much is it bouncing this time? That's like half. How high is it going this time?
I'm not even sure how to solve 1/3
Yeah,
of
this is tricky, right?
13.
Yeah. This is tricky. I mean, it's going to be close to 12 divided by 3. You know what I'm saying?
Okay. So 4-ish.
It's going to be 4-ish. Yeah. I'm gonna literally write that. 4-ish. On the way up. And 4-ish on the way down. And I'm getting really small here on the whiteboard. I'm going to zoom in again. So 4-ish, 4-ish. It's going to give you 8-ish. But that should take us up over 230 now, right?
Yes.
Okay. That should. And it does. We don't even have to calculate it. We don't even have to calculate it. Let's go back to the question. Right? The question is, how many times does the ball hit the ground before it has traveled a total of over 230 vertical feet? How many times?
4 times.
4 times. 4 times. That's when it's over 230 vertical feet. It might be tempting to be like, if 3 were an answer, and thank God they didn't put 3 as an answer, I would be tempted by 3. You know what I'm saying? I would be tempted by 3 because that would be before it's 230 vertical feet. But they want to know how many times does it hit the ground before it's traveled a total of over 230 vertical feet. We've got it at 4, right? We've traveled over 30 vertical feet, and that's the question, at 4. It's answer choice A. Any questions about that?
Nope.
Okay. Draw a picture. You've got to think about the question the right way. You've got to conceptualize it the right way. And here again, we didn't even have to calculate precisely what, a third of 13.3 repeating was. We didn't have to worry about that. B, C, and D are crazy. D? It's not going to have to bounce 100 times. No, I mean, close to 8. We've got it at 4. We're over 230 vertical feet. Not a lot of operations here. Just understand what the question's asking you and conceptualizing it the right way. Does that make sense, Karis?
Yes.
If you can draw a picture, draw a picture. I don't even know how to begin thinking about this one without drawing a picture. I don't even know how. I'm not interested in it. I couldn't. I don't think most students could. But once you draw a picture, it's just basic logic. Does that make sense?
Yes.
All right. Go and read question 103 for us, please. There's a lot going on here with this question.
Planet Z has an atmosphere of 40% nitrogen, 25% oxygen, and 5% carbon dioxide. The rest of the atmosphere is made up of argon, methane, and another gas, gas Q, that is not found on Earth. Planet Z's atmosphere contains twice as much of gas Q as it does of argon and methane combined. Which of the following is false?
What are we solving for here?
Which statement is false?
Yeah, which statement is false? Before we even attempt to read and test the answer choices, I think we just have to understand what's going on in the question. We've got to conceptualize it the right way first. Okay? I think the perfect way to do that here is to draw a pie chart. Let's draw a pie chart. You're familiar with pie charts, right?
Yes.
Okay. All right. All right. So in this question here, we've got planet Z. It's 40% nitrogen, 25% oxygen, and 5% carbon dioxide. Let's start there by just outlining that information in the pie chart. Okay. So let's represent the 40% nitrogen. 40% is going to be close to 50%, but not quite. So that's something like 40% right there. Do you see that?
Yes.
Okay. So 40% nitrogen. I don't know what the atomic symbol for nitrogen is. Whatever. Maybe it's N. I don't know. Okay. Nitrogen. There we go. 25% oxygen. That's going to be easy, right? 25% is just a quarter of the pie. So that's like this right here. 25% oxygen. Okay. Apologize for the terrible handwriting. 5% carbon dioxide. This is going to be a little sliver. I mean, we don't have to be perfect here, but it's just a little sliver. Okay. That even might be too big, but that's all right. It'll give me space to write. 5%. Oh, I know this one. Carbon dioxide is CO2. That's easy. And then it says the rest of the atmosphere is made up of argon, methane, and another gas, gas Q, that is not found on Earth. Okay, so I guess I'm going to zoom out just a little bit. So this last remaining amount here, from here to here, what percent is that, by the way?
That would be 30%.
Yeah, it's 30% right there. That's 30%. That even looks like 30%, right? It looks like a third of the pie. That worked out kind of nicely. Okay. Okay, and that is okay. So that's made up of. Let's see. It contains twice as much of gas Q as it does of argon and methane combined. Ooh, do you understand what that statement means, Karis?
Kind of.
Contains twice as much of gas Q as it does of argon and methane combined. So what is there more of? More gas Q or more argon and methane?
More gas Q.
More gas Q. In fact, it's twice as much as argon and methane combined. I think we know the percentages here. What percent of that remaining 30%, what percent is gas Q?
Would that be... I'm thinking 15, but I'm not confident in that.
15 would be half of that 30%.
Okay.
But it's not half of it. Right? There's twice as much gas Q as argon and methane. At the very least, we can represent it physically.
Oh.
Right? Here's gas Q. Right? There's twice as much as argon and methane. Right? Do you see that? I just represented it physically.
Okay.
Okay. I'm going to write methane, not leave it as meth. All right. Now you know the percent. Right?
It would have to be 20%.
20% gas Q. Yeah. And what percent is argon and methane?
10%.
10%. Booyah. Does that make sense how we figured that out? Just logically.
Yes.
Let's double check and make sure everything adds up to 100%. Right? Let's double check. Nitrogen, oxygen, that's going to be 65% plus 5% CO2, that's 70%. Plus 10% argon methane, that's 80%. Plus 20% gas Q, that's 100%. Perfect. We got it. We got it. We have successfully conceptualized the question the right way. Does that make sense?
Yes.
This is going to be a lot easier now. A lot easier to test these answer choices. We got to find the one that's false. Don't forget that, right? We're not finding the true statement. Which of the following is false? So there's going to be 3 true statements and one that's, well, false. Let's test these. Go ahead and read answer choice A for us, please.
The atmosphere contains more oxygen than gas Q.
Okay, is that true or false?
That's true.
That's true. It's 25% oxygen, 20% gas Q, so that's true. And strangely, because it's true, we can get rid of it. Because we're looking for the false one. Go to read answer choice B.
The atmosphere contains more carbon dioxide than gas Q.
Does the atmosphere contain more carbon dioxide than gas Q?
Not even close.
Not even close. Gas Q's got 20%, carbon dioxide is 5%. B looks like it's false. So let's keep it. We're looking for the false one. I want to test the others, though, because we might be missing something. Go and read answer choice C.
The atmosphere contains half as much carbon dioxide as argon and methane combined.
Is that true or false?
That's true.
That's true. There's 5% carbon dioxide, 10% argon and methane. So, yeah, it's a true statement. Because it's true, we get rid of it. Because we're looking for the false one. Go ahead and read answer choice D.
The atmosphere contains twice as much nitrogen as gas Q.
True or false?
True.
True. So we get rid of it because we're looking for the false one. We found it already. Answer choice B. Any questions about that?
Nope.
No. This is such a good example of a question where, like, if you didn't conceptualize, if you just read the question and we're trying to go directly from the question to the answer choices, it would be a nightmare. It would be a nightmare. I wouldn't even know how to think about it. But the real work here, Karis, and those of you watching the recording, the real work here in a question like this is thinking about the question the right way first. That's the real work. Is that clear?
Yes.
You've got to understand the question. Understand the scenario described. You can draw a picture. I wouldn't know how to do this without drawing a pie chart. I wouldn't want to. Wouldn't want to even try. I mean, there may be a way to, like, list out everything. You could probably do that too. I think it's just much easier to think about with a pie chart. It is. But it's all about thinking about the question clearly. And then, of course, directly answering the question. All right, you're not looking for the true statement. Some students are probably going to they might even go through all this process and stop at answer choice A. They're like, oh, that's true. Nailed it. And stop there. Don't do that. Don't do that. Make sure you answer the question being asked. Which of the following is false? That's B. Any questions?
Nope.
Okay, great. And we got one more question here involving basic logic and drawing some pictures. Then we'll take a little break here. All right. Go ahead and read question 107 when you see that on the screen, please.
Two companies are exclusively competing in a new mobile market. If Company X had 24% of the market share in 2016 and Company Y captured twice as much of the market share in 2016 as it did in 2015, then which of the following must be true?
Okay. And they give us 3 statements here. Some of them may or may not be true. We'll find out. This is, if you just jump right into the options in the answer choices here, like Roman numeral 1, 2, and 3, it's really confusing. Like, read Roman numeral 1. Go ahead and read it for me.
Company X had 62% of the market share in 2015.
I don't know. Do you know if that's true or not?
I have no idea.
I have no idea, right? We don't even know what its market share was in 2015. We haven't figured it out yet. Read the second Roman numeral.
Company Y had more of the market share in 2016 than Company X.
I think that one's pretty straightforward. Maybe, maybe not. Maybe, maybe not. Do you know if that's true or not?
I think that one is true.
I think that's true. Let's do this. Let's step back. Right? Let's step back for a minute. Let's do the same thing we did last time. Let's draw some pictures here and conceptualize this the right way first. So we've got 2 years here, right? We've got a 2016 year. And then we've got, we'll start there. I think we got to deal with 2015 here in a minute too. Let's just conceptualize it. Company X has a 24% market share in 2016. That's easy to draw, right? Can we draw that?
Yep.
I think so, right? It's close to a quarter. So something like that. That's Company X. That's 24%. Does that make sense so far?
Yes.
Okay. What can we conclude from that? If Company X has 24%, we know how much Y has, right?
It would have to be 76%.
76%. Y is 76%. Has to be, right? Because they say these two companies exclusively compete in this mobile market. So there's no Company Z or anything like that. It's just X and Y. Great. Let's try to represent the 2015 values as well. That is a horrible circle. Deal with it. It's really lumpy. Okay. So the 2015 year, let's see. This is ugly. Company Y captured twice as much of the market share in 2016 as it did in 2015. So it had twice as much in 2016 as 2015. This is Company Y. I think we can figure out how much Company Y had. How much did Company Y have in 2015?
Would that be 34%?
It's going to be half of 76, right?
Okay.
It's going to be half of 76. I don't think it's 34 because 34 times 2 is 68. Right?
Okay. Yep.
Like 35 times 2 would be 70. You see where I'm going with this?
Yes.
So it's got to be bigger than 35%. Not a ton bigger, but bigger. Do you know what percent it is?
Like 37?
I think 37 would be 74%.
Oh, so I'm still 2 off.
Yeah. You're 2 off. It's 38.
Okay.
It's 38. I mean, if you want to divide 76 by 2, you could do it. It's not too bad, right? 2 goes into 7. Wait, I mean, that goes 3 times. Oh boy, we get into the division here. Some of you may be familiar with this, maybe not. Right? Is that operation familiar? When you're dividing?
Yes.
Yeah. And then 2 goes into 16 8 times. You could do that if you wanted to. We just play with numbers kind of like we did. But it's going to be 38%. Any questions about that?
Nope.
Okay. So 38% is just a little bit more than a third, so I'll just draw a little bit more than a third. I don't know, that lumpy circle. That's Y. And so we know what percent X had in 2015, right?
It would have to be 62.
Yes, exactly. 62 is company X. Okay, great. This is going to be really easy to test these answer choices now. We've drawn out all the information. Read Roman numeral 1 for me again.
Company X had 62% of the market share in 2015.
True or false?
True.
True. We know it. Absolutely. Roman numeral 2. Read it for me again.
Company Y had more of the market share in 2016 than Company X.
True or false?
True.
Absolutely. Right? I mean, look at it in 2016. Y definitely had more. What about Roman numeral 3?
Over 3/4 of Company X's business is outside of the mobile market.
True or false?
It hasn't said anything about that.
I have no idea. Yeah, I don't know anything about it. Does it say anything about its business outside the mobile market in the question?
No.
We have no clue. It certainly doesn't have to be true. What's the answer here?
B.
Let's B. Do you see how relatively straightforward that is once you draw out the information?
Yes.
I recommend that. But again, there's no big calculation here. I mean, you got to find half of 76. Okay, fine. But it's just thinking about the scenario the right way first. That's all. It's a good investment of your time to draw a picture if you can draw a picture. Draw out the information. Flesh out the ideas first. Think about it the right way first. And then try to answer the question. Does that make sense, Karis?
Yes, it does.
Okay, good. That's the name of the game here on word problems like this. And always draw a picture if you can draw a picture. We're going to see more of this, especially when we do geometry. Good heavens, when we're getting to geometry. You're going to have to draw some pictures. We'll practice that a little bit later in the course. Let's take a little break here. We are going to come back and do some graphing questions here in day 3, part 2. So get ready for that. In the meantime, go ahead and run to the restroom. I'm going to get some more coffee myself, and then I'll see you here in just a couple minutes, all right?
Okay, sounds good.
Thank you, Karis.